Hi, good morning. Today we are going to discuss the blow room. We will start with the impurities and contaminants that we see in cotton. The blow room consists of a set of machines connected together in series. So, blow room is not a single machine, there are quite a few machines in the blow room. We call it blow room line usually, and these machines are connected together in series. The material that we process is transported from one machine to the other by pneumatic means and by conveyors. So, these are the two means through which the material goes from one machine to the other. And the primary objective of the blow room is to open, clean and mix the material in topped form. So, we will see how these three objectives are actually accomplished as we go through the course. Now, one important objective which is mentioned here is to clean. The moment we say clean, that means there must be some impurities in the material. Now, impurities can be found in natural fibers. In the present case, it is the cotton which contains lot of impurities in it, and hence cleaning is specifically important for cotton. If we use the blow room for processing man-made fibers, let us say viscose rayon or acrylic or polyester or nylon or any other synthetic fibers or man-made fibers, these fibers do not have any impurities in it, and therefore, cleaning will not be necessary for such fibers in blow room. However, it is only important for cotton. Okay. So, therefore, we first try to understand what are the impurities and what are the contaminants which are present in the cotton fiber. The cotton arrives in the main in the form of a bale, and the bales are shown on the right hand side. Here these are the bales. You see, excessive pressure is used to convert the fibers into tangled and matted mass while we make these bales. See, these are first of all covered by a sheet and there is wrapped by some tapes, because the bale has to be transported or the cotton has to be transported from field to the mills. So, fields are somewhere else. The cotton goes from field to the ginners first. In the ginning machines, what we do? We try to remove seeds from the cotton fibers. As the cottons are plucked during harvesting time, it contains lot of seed. So, the first stage of processing of cotton is to actually remove seeds from the fibers, and this is performed by ginning machines. Ginning machines are not really a part of the textile mill. Now, in the ginning machines, seeds are removed and the fibers are separated out, and then these loose fibers are compressed in the form of a bale as it is shown in the diagram. The bale contains a lot of impurities. The ginning process cannot remove the impurities. The main purpose of ginning is basically to separate the seeds from the fiber. The fibers are attached to the seed, and hence we have to remove the seeds from the fiber first. So, that separation is done on ginning machine. Anyway, so the bale from the ginning plant arrives in the mill in the form of a bale. Now, these bale contains lot of impurities, and quality of the yarn and the life of the machine suffers due to these impurities. It is therefore mandatory to clean the fibers first before their actual processing begins. So, the first job is to clean the fibers. Okay. Some cotton bales are shown here. The cloth has been removed, and you still see the way the bales look like. They look like a rectangular box type. Typical size is given here as shown. This is typical size. This size can vary. Typical weight also is given. Average density is something like this, 0.2 gram per centimeter cube or 195.4 kg per meter cube. And the density range is could be from 160 to 240 kg per meter cube. So, these are the typical values which is quoted here, and this gives us an idea that the kind of pressure which is applied while transforming the floppy fibers into bale, the density of the bale goes close to 200 kg per meter cube, or if we are interested in gram per centimeter cube, it is 0.16 to 0.24 gram per centimeter cube. All right. You must remember this is actually much less than the cotton fiber. Typical density of cotton is how much? If we say density of cotton fiber, which is close to 1.52 gram per centimeter cube. This is the density of fiber, and this is the density of fibers in bale form. So, this is the fiber and this is the bale. So, you can see that even if we have given so much of pressure, still the density of the bale is much less than the density of individual fibers. Okay. Now, we must know what are the type of impurities which are present in cotton, because if we know this, then this knowledge will help us to suitably design the machine which will be able to extract the impurities from the bales. Now, the impurities can be classified into 4 categories as shown here: vegetable matters A, mineral matters, others, and fiber fragments. Now, within vegetable matters, what are there? Husk, seed fragments, stem fragments, leaf fragments, and wood fragments, and this constitutes 50 to 80%, a very large quantity is actually vegetable matter. And what problem we can face if they are still left in cotton? There will be drafting problem, which you will see that there are some machines where there is operation called drafting, and it will also create problem in the processing performance of the machines, and there will be lot of faults in the yarn. So, these are the problems which we are going to face if the vegetable matters are not removed, if we leave them. The other thing is mineral matters, and mineral matters are earth, sand and dust. Their quantity is relatively less, it is around 10 to 25%, depends upon the variety to variety, depends on the country of origin, depends upon the area in which the cotton has been grown. So, these values, therefore, a range has been given, and if we have these mineral matters, they cause deposits and very high wear rate, that the machine's life will go down, because these earth and sand particles are very abrasive, especially the sand particles. They are very hard and they will damage the parts of the machine. The other type are what? Metal fragments, cloth fragments, packing material like jute, polypropylene. These materials are used to pack the bale. There could be metal fragments like nails could be there could be cloth fragments, some cloth because from the packing material this can generate, that could be sometimes piece of leather. So, many things could be there, and they can also damage the machine part, they can cause breaks, yarn breaks, and they could be a source of foreign fibers in the yarn. And we will see later on that this is a great nuisance, presence of foreign fiber in the final yarn. This will spoil the yarn, this will spoil the fabric, this will bring down the quality of the final fabric, and the mills are very concerned about the presence of foreign fibers in the yarn. The other things are fiber fragments. A major part of the dust is basically the fiber fragments. These are micron level dust, and these dust is a source of health related issues. Those who will be working in front of the machine or operators, they may have health issues because of inhaling this dust. So, these impurities are present, we know their quantity, their type and what kind of problem they can create, and therefore, we have to get rid of them. So, roughly we can say that in these impurities, fiber fragments, leaf, husks and seed coats. What are seed coats? Seed coats are basically fragments of seeds. While we try to separate out the fibers from the seed on the ginning machine, what happens? That the fibers are so tenaciously attached to the seed that as we pull the fibers out from the seed, the fibers, as soon as they come out from the seed, the coating part of the seed also comes off along with the fibers, and these tiny coatings of the seeds remain attached to the fiber. These are known as seed coats. This is also vegetable matter in a way. So, this quantity, as we have discussed earlier, 50 to 80%, sand and earth we have also seen in the previous slide, 10 to 25%, and there could be some water soluble material which is 10 to 25%. The particle size, trash trash is nothing but leaf particles, husks, seed coats, sand, everything is put together, is in a way clubbed together, is called trash. Their typical size is more than 500 micron, they are quite large in size. So, if we classify them according to size, then some of them are more than 500 micron, the dust is less than 50 micron and the micro dust is less than 15 micron. So, we have to tackle the size of these impurities. Some of them are bigger in size, some of them are very, very small in size. So, the size, type and their nature, these informations actually can be used to design suitable machines. The contaminants is the foreign matters in cotton, and these are all termed as contaminants, all foreign matters. These are jute, cotton and plastic strings, feathers and leathers, bird feathers, it could be metal wires, grease, oil, rubber, tar, human hair or animal hair, gutka pouches. These are all contaminants. So, they are not a really natural source to the cotton fiber, but they arrive along with the cotton bale in the mill, and these are also a source of problem for the spinning mill, and some pictures are given here just to show. These are the another type of impurities in cotton, but they are classified as contaminants. Okay. Next is the contaminants appear in the bale due to human negligence involved in handling cotton at different stages of their processing, starting from harvesting to bale formation in the ginning mills. As I said, they are not appearing naturally, but they are only because of the human negligence. It is imperative for a mill to extract them as early in the processing as possible, so that damages to the machine and process is kept minimum. So, we do not allow them to go further, and we want that these contaminants are removed as early in the process as possible, because if they move further they becomes more and more difficult to remove, because as the process goes on these contaminants become smaller and smaller in size, and some of them can be also lighter than cotton, and therefore, their removal becomes more and more problematic, more and more difficult, and hence we should try to remove them as early as possible. Now, how to get rid of unwanted trash particles? What is the basic mechanism that we can follow? Weaken or break the bonds between the particles and the fibers by mechanical means. Somehow we have to weaken or break the bonds between the particles and the fibers, and this can be broken by mechanical means, that is by applying mechanical energy. Separate or extract the particles from the fibers. Once you have broken the bond between them, in a way they are liberated from the fibers. Now, we have to go for separation or extraction of the particles from the fiber. So, opening, blooming and loosening of the structure of compressed tufts is the prerequisite for cleaning. So, if we want to clean the material, then we have to open them, bloom them and loosening of the structure. This has to be accomplished first, and then we can think of cleaning them. So, this information is important from the point of view of the designing of the machines. Physical and mechanical properties of fibers vary from bale to bale. So, each bale, so many bales are coming, and the properties of the fiber in each bale is also not same. So, if we take out fibers from different parts of the same bale and measure their properties, fiber properties, we will find there is a variation in it. Besides, bale to bale variation also could be there in the properties of fiber in terms of its length, fineness, maturity, trash level, color, many things. You will be taught about the fiber properties in some other course, and you will find that many of these properties vary from bale to bale and within a bale, and hence mixing of fibers belonging to different bales is therefore very important to produce a yarn of consistent quality along its length, and hence therefore mixing is an important objective that we have to accomplish right at the beginning. Early the mixing process is initiated, better will be the degree of mixing of fibers, and hence mixing of fibers in the form of tufts is also initiated in the beginning of the process by the machines. So, mixing of tufts are initiated in the blow room machines. We cannot really mix in the fiber form right now. The bales are converted into tufts. The tuft size you will see gradually reduces, and we mix the tufts. So, that also needs to be initiated in the blow room itself. Therefore, the objectives of the blow room becomes opening through which we will be able to break the bond between the fibers and the trash particles. We will be able to go for cleaning subsequently. Once the bonds are broken, we get an opportunity to extract the trash particles from the cotton fibers. At the same time, we also go for mixing of the tufts. These three therefore becomes primary objectives of blow room. Other thing that we need to remember, that is at least one of the objectives should be accomplished prominently to justify the commercial viability of the machine. Now, if we think of designing a machine where we have to accomplish these objectives stated in the previous slide, then we have to remember that at least one of the objective should be permanently accomplished by the machine in order to justify the commercial viability of the machine. The process should be economical to any alternative system that can be thought of, and the overall commercial viability also has to be seen. And the last is the interaction between the machine and the fibers should be such that fibers do not get damaged. This is very important fact, that whatever machines are designed, we have to ensure that the fibers do not get damaged. They are very delicate, they are very tiny, they are not very strong, and hence the machines, when they are working on the fibers should not get damaged, it should not break. This also is equally important. With this, we stop this very first lesson of blow room. Okay? Thank you.